Hi, my name is Manuel Ortiz Lopez. I am in Energy and Transformation 2, and my experiment is Homopolar motor experiment. The problem and question. Well, in problem, the homopolar motor increases motion using a battery, magnet, and wire. Many people don't understand how this is a simple experiment. The project explores the physical principles behind the motor's movement, and this experiment focuses in the Lorentz force. I have two questions. The first one is how is this related to Lorentz force and how does the interaction between electric current and a magnetic field generate rotation in a homopolar motor? The objectives and hypotheses analyze the effect of material variations on homopolar motor efficiency, explore the different applications of Lorentz force in simple electric motors. And my hypothesis is if the copper wire thickness increases, the speed of rotation will decrease due to increased friction. The justification. Well, in scientific contribution, I put like it helps to understand electric motors and generates and improves an experimental skills. Knowledge in other areas, it connects physics with engineering and technology. The contribution to peers, this encourages discussion and collaborative learnings and promotes exploration beyond theory and sustainability and ethics. This supports energy efficiency, tech development, and knowledge sharing. So the next one is introduction of my experiment. This is the electric motor like you see every day, like a car or different tools. And the monopolar motor is one of the simplest motor designs. And understand how electric current and magnetic field work together to create motion with battery, magnet, and copper wire. The methodology one is variables, materials, and equipment used. The independent variable is copper wire thickness. The dependent is number of rotation, and the control variables is battery voltage, wire type, surface used, room conditions. The materials are the same with neodymium magnet, and the flat is non-conductive surface. I use like a table with wood. Methodology two. Well, this is the process. The first one is choose a flat wooden surface. Second one is attach medium magnet to the negative terminal of the voltage. Then shape copper wire so both ends touch the battery and the magnet. Observe wire rotation caused by Lorentz force. Repeat the same experiment with different type of thickness like thin, medium, and thick and record rotation speed and stability for each configuration. And this is the materials like I used. In the results and data collection, here is my data collection. Um, I collect the data by measuring the number of rotation in 10 seconds for each wire thickness. Each wire type is thin, medium, and thick. I use a stopwatch or a timer to measure time and then rate stability. The scale is 1 to 5. All results were recorded in a data like this one. And here is my results. The average rotation, stability, and average stability. Test 1, test 2, and test 3. And here is my video of the results. This is my experiment. The data analysis. Here is my hypothesis confirmed that the data shows that the copper wire increase and the number of rotation decrease. These support the hypothesis. Then the thin wire allowed for more movement and faster, more stable rotations, and the thick wire is in slower and less stable performance. And this confirms that wire thickness is a key factor. There are the different like thin, medium, and thick. My conclusion, the experiment confirmed that copper wire thickness directly affects. Using a thin wire result in more rotations and faster. The thicker is increased friction and less flexibility. And the results support the original hypothesis. The limitations. Here is the results. Simple model, complex model behavior, the small scale. Influencing factors, there are environmental, surface friction, magnet strength, and the risk by phase is the analysis and the battery overheating. In my critical question, what is the importance of the scientific method and why is its importance in science? Because it provides a logical process to explore a question, test hypotheses, and solve problems. It helps you to verify results, reliable, and which is essential for building scientific knowledge. And it promotes overthinking, objectivity, conclusions, and helping scientists avoid bias. And then my critical question two, what have you learned from doing this activity? I learned how electric current and magnetic fields interact to produce motion. I improved my skills in building, testing, and analyzing physical systems, which helped me connect physics concepts like motion, energy, and forces. And my knowledge of energy conversion, like energy becomes kinetic energy, which relates to topic like power and work. Sources, the reference, and that's all. Thank you.